In this video, we're going to look at section 7.6, the tangent function. So consider the unit circle. So we have drawn here an angle, and it's on a circle of radius 1 centered at the origin. We know that the tangent of theta is opposite over adjacent, which is y over x, and we also know it as the sine of theta over the cosine theta. Another way to think of this is as the slope of the line through the origin and the point on the circle. So you can see that, the rise over run, if you will, is that our slope is going to be y over x, which is exactly the tangent of theta. So we can use this and know that, for example, if we look at a 30-degree angle, then its rise over run, its slope, is going to be the tangent of 30 degrees. And we can do that on our calculator and get 0.577. So it's a little bit more than a half. You can also do it because these are values that we know from memory from our chart, that the tangent of 30 is sine 30 over cosine 30, and that the sine of 30 is a half, and the cosine of 30 is square root of 3 over 2. And so we can see that that's going to be 1 over square root of 3, or if you like, rationalizing it would be square root of 3 over 3. So there's another way of thinking of our tangent theta is as the slope of the line through the origin. So let's build on that a little bit because we want to talk about how we're going to graph y equals tangent x on an xy axis. So I'm going to slide this up if I can. So thinking of tangent of theta as the slope, we can see that the tangent of 0, as you come along this angle here, a horizontal line has a slope of 0, so that means that the tangent of theta is equal to 0. We can see as we move along the unit circle and the angles get bigger, as theta moves from 0 towards pi over 2, you can see that these become steeper and steeper lines, and so those slopes are getting larger and larger, and they're positive because we're rising as we go from left to right. Now, when we get all the way up to pi over 2, that's going to be a vertical line, and we know that the slope of a vertical line is undefined. It doesn't exist, so that means that the tangent of pi over 2 is also going to be undefined. And we can see, because as we move along this way, that these slopes are getting bigger and bigger, we can think of this, the reason it's undefined is that this slope, this limit as x approaches pi over 2, as we come in from we say the left, meaning in terms of an xy axis. That is we're plugging in angles that are smaller than pi over 2 and approaching pi over 2 using angles that are smaller than pi over 2, that limit is going to be infinity. So that means we can say we know that tangent of 0 is 0, and we know that as we approach pi over 2 from the left, we're going to get positive values for tangent that are going to go to positive infinity. So there's a part of our graph. Let's explore this further. So if we now go back to an angle of 0, so we come back to here now, and then we move our way going clockwise. Now these are negative angles. As we work our way down towards negative pi over 2, we can see that these lines have negative slope and that they're getting to be bigger and bigger negative numbers. That is, we can say the limit as we approach negative pi over 2 coming in from the right, because remember a smaller negative is bigger than a bigger negative, then this slope is going to, this tangent then is going to approach negative infinity. So what we know is the tangent of 0 is 0. As we approach pi over 2, it's going to go up to positive infinity. As we go towards negative pi over 2 coming from the right, it's going to go to negative infinity. And so there is a graph of tangent of theta in between negative pi over 2 and positive pi over 2. Now, we also know that tangent of theta repeats itself. So as we work our way going in this direction, so here's pi over 2, and now we're going to get bigger and bigger numbers as we work our way towards 3 pi over 2. And at 3 pi over 2, we're going to be 0 again. So we know that between negative pi over 2 and pi over 2, it was going to look like this. Then we can see at pi, it's going to be 0 again. And then we're going to work our way as we come this way back towards negative infinity. So it's coming from positive infinity, or from rather, as we go this way, we're going from positive infinity over to, these are now going to be negative slopes. So it's going to be negative infinity just on the other side. And we're going to see that this repeats itself over and over again for our tangent curve. Something like that. So we say that that our tangent curve now has a period of pi, because it's going to repeat itself as we go from negative pi over 2 to pi over 2. Then we're going to get the same copy of that from pi over 2 to 3 pi over 2, and so on. Now, we don't talk about amplitude for a tangent curve because we wanted to go max minus min divided by 2, but there is no maximum and there is no minimum. So it's not really a relevant question to ask what is the amplitude of a tangent function. Now, also notice that at pi over 4, sine of pi over 4 and cosine of pi over 4 are both square root of 2 over 2. And so, since tangent is sine over cosine, that's going to make the tangent of pi over 4 1. So we're going to know another point on there at pi over 4, 1. And at negative pi over 4, when we come over here, that's going to be equal to negative 1. So when we graph these tangent curves, just like we did in the case of a sine and a cosine, we have important values that are going to be every fourth of a period. So we're going to look at what the value of the tangent is at the beginning and end of the period, where it's going to begin and end with asymptotes. In the middle, it's going to be 0. And at pi over 4, it's going to be 1. And at negative pi over 4, it's negative 1. So notice this tangent curve rises from left to right. It's kind of suggestive of a cube function. But remember, a cube function doesn't have a vertical asymptote. So they are not exactly the same. Okay. So notice we have x-intercepts are going to be where the numerator is 0, which is where sine is 0, and those are going to be multiples of pi. So 0, pi, 2 pi, negative pi, and so on are going to be where the tangent curve has an x-intercept. The vertical asymptotes are going to be, I'm going to call them at the over 2's. That's where the denominator is going to be 0. And cosine is 0 at pi over 2, 3 pi over 2, 5 pi over 2, and negative pi over 2, negative 3 pi over 2, negative 5 pi over 2, and so on. So the idea is the slope of a line through the origin forming an angle of 7 pi over 2, 7 pi over 8 rather, with the x-axis. So it doesn't really matter where the line is. What matters is that if the angle that it forms, let's see, 7 pi over 8 is going to be almost pi. So no matter where that is, this angle, if this angle is 7 pi over 8, then the slope of that line is going to be the tangent of 7 pi over 8, whatever that might be. And we don't know this one from memory, so we'd have to go to our calculator. But that would be a negative value, as you can see, because the line's going to fall from left to right. So let's see how we're going to graph a tangent curve. So we are going to see that the period is going to be our natural period, which is pi for a tangent, divided by b is going to be pi over 2. We're still going to have these critical points that are going to appear every fourth of a period. And so for us, that's going to be every pi over 8 in this case. Now, there's no translation horizontally or vertically here, so we're going to say that a tangent is going to start in the middle. So it's going to start right at the origin. I'm going to put a tick mark here, pi over 8, and a second one, which is 2 pi over 8 or pi over 4, is going to result in a vertical asymptote. Resetting back to the middle, to where we started, going to the left at negative pi over 8, and then another critical point, which is negative 2/8 or negative pi over 4, we're going to have a beginning asymptote there. Now, at the quarter period over, when we go over one tick mark to the right, that's going to give us a value of tangent that's 1. When we go one tick mark to the left, that's going to give us a value of tangent of negative 1. So these are the 4 values, if you will. You know, well, 5 counting the beginning and end. So it's going to be an asymptote, a low spot, 0, a high spot, and an asymptote. And then we're going to connect that with a curve that's going to rise from left to right and kind of swirl as it goes through the middle of our graph. So there's one period or one cycle of tangent of 2x. Okay, I'm going to slide it up a little bit. Let's see how we're going to do the tangent here. So our period, because there is only a 1 in front of the x, our period is still going to be pi. We're going to put our tick marks every fourth of a period, so every pi over 4. Now, because of this minus pi over 4, we're going to translate this to pi over 4 to the right. So that's going to be pi over 4. I'm going to put another tick mark at another pi over 4 added to that, which is 2 pi over 4, which is pi over 2. I'm going to go another tick mark, which is going to make that 3 pi over 4, and that's going to be an asymptote. I'm resetting back to the middle, and I'm going to go one tick mark to the left, that's 0. Another tick mark to the left is going to be a negative pi over 4, and that's going to be an asymptote. Now, we didn't translate this up or down at all, so our tangent is still going to start in the middle. Now, this has been stretched vertically by 3, so when I go one tick mark to the right, instead of going to 1, I'm going to go to 3 times 1, which is 3. And when I go one tick mark to the left, which is right on the y-axis, I'm going to go down to a negative 3. And then here is going to be our tangent curve, which is going to rise from left to right. Okay? Okay, let's make it even more complicated. So here it has not been factored, so as we have before, we're going to first factor this thing. So now it's going to look something like that. So our period, which is going to be the natural period pi, divided by pi over 4, is going to be 4. There's our period. Our tick marks are going to be every fourth of a period, which is going to be every 1. So we are going to start this going 1 to the left. So we're going to get a negative 1, and then 0, the y-axis, will be a critical point, and at positive 1, that's going to be the end of our first period. So I'm going to make that be a vertical asymptote. I'm going to go 1 to the left is negative 2, and another to the left is going to be at negative 3, and that's going to be an asymptote. We have moved this up 1, so when we start in the middle at negative 1, that's going to actually be at a y value of positive 1. Because of the 2, we're going to stretch this, so I'm going to need to go 2 up and 2 down to get those one critical point right and left. Because of the negative, it's going to be a reflection in the x, so instead of rising from left to right, it's going to fall from left to right. So at that one tick mark to the left, at negative 2 here, we're going to be all the way up at 3, and one tick mark to the right, which is going to be on the y-axis, is going to have a y value of -1, and our reflected tangent curve is going to fall from left to right. All right, very good.